All right. All right. Welcome, everybody. Thanks for joining us for this presentation. It's basically what we're going to do is we're going to do a recap of the OpenSIL announcement that was made in Prague earlier this year, and followed by updates, followed by a little demo from AMI. My name is Raj Kapoor. I'm the Chief Firmware Architect for AMD. And
this is Srini from AMI, Director of Engineering.
Right, thank you. All right, let's go ahead and get started. All right, so there was a problem statement, and it provided us with a unique opportunity to solve some of the very interesting problems that we had within AMD. We were unable to scale with the silicon initialization firmware. We were unable to scale from a UEFI-based firmware, host firmware solution to, let's say, any other solution such as coreboot. So it was possible, but the solution was it was a Herculean effort solution. And so we had to spend many cycles, many resources, many months to get a solution up. And there was no way to backport it either into the system. So on every generation, we had to turn the wheels over and over again. So like I said, it was an opportunity for us to do something about it. And we embarked on our journey to create something called as OpenSIL, Open Silicon Initialization Firmware or library. Now, the problems, the AGISA, as we all know, if you've been using AMD systems, if you've been integrating the silicon onto your platforms, you know that AGISA was a fantastic solution. It still is for UEFI-based host firmwares. However, you could not marry it with coreboot or any other firmware solutions. So it was the other problems with that was that it was closed source, and there were challenges to address all the market segments and whatnot, and it just was not seamlessly scalable. So the requirements with which we set off to design OpenSIL was that the architecture, it must be extensible. It must be a very simple architecture, very modular enough to scale between different host firmwares. What AGISA was, the challenge with AGISA was that it was written with UEFI, for UEFI host firmware. And there was a lot of UEFI-isms in AGISA, which we were not able to simply remove if you wanted to go to coreboot. So, so what we decided was it needs to be written in a simple language, should not adhere to any standardized host firmwares, must not adhere to any standardized host firmware architectures. It should be agnostic to any other host firmwares out there in the market today, and that also makes it scalable for future solutions as well. And it must be open source right from the get-go. What I mean by that is that these are the elements, these are the qualities that we set forth as challenges to design the new solution. So, and of course, the idea was not to replace UEFI. The idea was to add more host firmwares into the stack and make it scalable. So here's what it is. It's an agnostic 3 static library solution. There are 3 libraries: XIM, XPRF, and XUSL. I'll explain what those mean and what they do. Very simple and scalable. It is written in C, standard C language. It is very flexible in the sense that if you want to have a rich set of features, you can add those features into the OpenSIL. If you want it to be very lean and push all the complexity up north into the host firmware or into the OS, that could be done as well. Very simple. And that makes it very lightweight. And so from a security perspective, the attack surface reduces quite a bit. And of course, like I said, it is open source right from the get-go. It is not only open source, it is open architecture. There were a bunch of us that collaborated into the architecture. And I'll talk about our ecosystem partners for OpenSIL. And they were very instrumental in validating the solution as well. So today it is in POC stage. I'll talk about the roadmap in a little bit. But these were the tenets based on which OpenSIL was architected. Here's the XM library. Like I mentioned, it's a very simple library. It exposes just one main API. It's to initialize silicon. That's all about it, right? Now that initialization can be repeated multiple times depending on which stage of boot you are in. If you are in the very early stage, you initialize the silicon based on the initial boot. The next one would be once you've done your PCI enumeration, you can do further initialization and so on and so forth. But it is just that one API, right? Now, that is very cleanly separated. The silicon initialization part is separated from platform initialization. So things like GPIOs, they get pushed to the other library, not in the silicon initialization. So that's the next. XPRF stands for Platform Reference Firmware. So these are the things that the library exposes. It allows you to collect the DIM map, builds the ACPI tables, or at least the data that the host firmware can take and build the final ACPI tables to be pushed up north to the OS. And it also does it also gathers the PCI topology, which we refer to as the get NBIO topology structure. And finally, also, it gets a memory map as well. There are a few other APIs in the PRF library. I purposely left it out. Didn't have much space in the slides, but these are some of the main APIs. And then the third library that I don't talk about here, that is the USL. It's utilities and sys libraries. It is not exposed to the host firmware. It is only exposed to the two main libraries, and it uses that to initialize, to gain access to the registers, the SOC registers and whatnot. Now, here's a list of open source ecosystem. I don't think we could have gotten here without the support from all these partners. Fantastic. The initial discussions led to where we are today. It's a very strong participation from the IFVs, the firmware vendors. And we started off with two firmware vendors, AMI and 9 Elements. And today, I'm really excited and thrilled to announce that we have a third vendor inside as well. And we will see a lot of activity from them as well in the next summit in Lisbon. So here's the roadmap. We started off as a POC in 2020, in very early 2022. That was based on Milan platform. The second phase we just completed early this year. right after the Prague summit, we open sourced OpenSIL, which is meant for kicking the tires for the OpenSIL, for the open source industry to kick the tires with it. But it was still not complete because the host firmwares were not ready yet. So I think the host firmwares are ready. They can be open sourced as well. We're just waiting for some final formalities for the host firmwares to be released. And Srini is going to talk about that in a bit. The POR is for 2026, which is a phase 4 in 2026 timeframe. That is when we go with OpenSIL as production, as POR. And that's when we end of life the AGISA solution. And that is the time frame where we go full scale, all SoCs, not just server SoCs, but client SoCs as well. Okay. All right. So with that, I'll hand over to Srini.
Hello. Yeah. I'll be discussing about how someone can take OpenSIL library and add it to your UEFI firmware and create a full-fledged UEFI firmware for a AMD Genoa Onyx platform. Basically, you can take two paths, right? Easiest one will be to take Aptio Community Edition, and then there are steps that I'll be talking about to create a complete firmware. Or another way will be if you have a UEFI AGISA firmware, you already have a AGISA firmware for Genoa platform. So how do we go from there to add an OpenSIL solution? So that will be the another way of achieving it. So if you are going to take UEFI firmware with AGISA package is already included, then what do you do? So you go and remove these AGISA packages like module package, CBS package, and CPM package, and all the PA and Dixie drivers which consume those AGISA protocols or PPAs. You just go ahead and remove it and create a vanilla EDK2 bus. Or, as I said, if you have taken the community edition, you don't have to go through that removal process because you can directly come to this step. So there will be two OpenSIL repos AMD has published, open sourced. That will be one is OpenSIL and another will be UEFI AMD OpenSIL. So add these two repos as a Git module to your project, download the source, include that in Aptio Community Edition project. And then, the earlier one. Yeah, here what is going to happen is, so as he said, there are 3 entry points that are there in the OpenSIL, and the AMD OpenSIL will be the wrapper driver that is going to call into this time point 1, time point 2, and time point 3. And then more importantly, so in time point 1, after the SOC IP blocks are initialized, it is going to take the data and then create the hobs that are necessary for the rest of the UEFI firmware to execute. So this is actually, you consider that as an UEFI AMD OpenSIL is nothing but a wrapper which will convert your firmware agnostic OpenSIL library into UEFI knowledgeable, meaning all the Dixie and PE drivers can know what to do with it. So those wrapper is what the UEFI AMD OpenSIL interface does. Yeah, next one. So even adding that alone is not enough. So there are some platform packages, meaning ASL codes are needed, board porting is needed, and then there are some basic drivers like SM control Dixie driver or ACP enable SM drivers are needed. So those needs to be added in the platform package. Yeah, can you go next one, please? The final step will be to include the build infrastructure like platform tools, Python scripts, XML files, and image stitching tools. So after this process, you are going to get a firmware binary that you should be able to install and boot to a Windows operating system or a Linux operating system. Yeah. So, but you don't have to. We have done the heavy lifting already. So you guys no one has to do that process again. You will have a final Aptio Community Edition source with all these steps that I described already integrated, and someone should be able to download it, build it, and install and boot to Windows and Linux operating system. One small caveat here, this particular link is not active still. Maybe a week or so, I think someone should be able to download the source. The main call to action here is for everybody, OEM, ODMs, is download the source, go through the control flow, get familiarize yourself, and then, as I said, for when it is a POR, you should be able to roll this OpenSIL solution into your systems. That should be your takeaway from this presentation. Yeah.
Right. Thank you, Srini. All right. So this slide basically talks about how the OpenSIL is relevant to OCP. It does adhere to some of these tenets, OCP tenets. Scalability, of course. Now we can scale. When I say scale, it is a true scalable solution. What I mean by that is, within AMD, I can scale from one generation to the other, from one product to the other, right? Now, in addition to that, the vision is for it to be able to scale from AMD to any other vendor, to Intel, or for ARM, for that matter. That is the long-term goal. And that we will be able to achieve only when I go ahead and open source the specification as well. So as soon as you open the specification for anybody to go and adopt, and there are these efforts out there in the industry as well to make a common layer, a common API layer or a wrapper layer around any host firmware, and whereby you can scale from one silicon vendor to the other. So it certainly fosters that desirement. And so that's what we truly mean by scalable here. Openness, like I said, the design is open source right from the get-go. That was the main goal. And of course, fostering sustainability as well. So we do have live demos. AMI, you should visit the AMI booth for demonstration. But we also have a demonstration here as well, right? It's not a live one, but it's a recording, correct? And so what is coming next is a number of POCs that are going to be coming up. We will be open sourcing a client port of the OpenSIL. And the next generation server POC as well. So this is all in due course of time. We are going to be releasing all these open source OpenSIL as well, and with the host firmwares as well for them. Okay. Call into action. I would like to invite anyone and everyone, competitors, vendors, system integrators, to come partner with us. There is still a lot to do. The vision is not complete yet. There is a lot of work, and we don't have a lot of resources. So I am looking for help, and if there is any way you can partner with us to help move the needle faster and in the right direction, that would really help. So thank you very much. And one last slide. This is your, how do I, there you are. This is the, can we do it? No? Oh, snap. Okay, maybe I need to go off. How do I do that?
Get out of it.
Huh?
Get out of it.
I'm trying to, all right. Okay, now play. All right. All right, go ahead and speak to it.
Here. Yeah. No, we can take the questions meantime.
Does
Yeah.
anybody have any questions for us? Okay. Questions? Yeah, please.
I wonder, how do you configure it? You know, like you can decide whether to.
Hard of hearing here.
Yeah, go ahead.
How do you configure it? Like, for example, I don't want to have USB enabled or something like that.
So any configurability Any configurability happens in XPRF. That's your platform reference firmware that we supply, right, for the CRB platform, and then you can modify it to suit your netlist, your platform netlist. If you do not want USB, you can disable it there. Or even the CBS options, for example, the BIOS setup options, they are a responsibility of the host firmware, right? So so those settings come down from the when the host firmware is initializing the OpenSIL using either XPRF library or the main library. When it is coming down, the arguments are passed through those APIs. Right. So hopefully that answers your question. Oh, fantastic.
Hi.
Hey,
question?
Nilesh. Yes.
Hello, Raj. Yeah, thanks. Great stuff. My question is, in addition to, of course, the open source benefits and time to market, is there also like a cost and performance advantage by adopting this framework?
You know, the cost advantage is enormous. Like I said, the vision is finally to allow the system integrators to move or scale from one silicon vendor to the other. Now, what happens today is that you have, if you have a platform that can take 3 different silicons, right? ARM, Intel, and AMD, correct? Now you have to maintain 3 different teams. Now you do the math.
All right, thanks.
Hey, Raj and Srini, nice presentation, guys.
Oh,
so this aligns really well with the USF model, if you guys are aware of that.
yes.
And a bootloader agnostic FSP model.
Yes.
So I think we should start collaborating more jointly.
Absolutely. Absolutely.
More about this more quickly.
Yeah.
And also, the OpenSIL is a framework interface pretty much, right, between the XSIM and the XPRF. So when you talk about open, is the XSIM source code also getting open? Or
Yes.
Okay.
Yes. The entire silicon initialization is open source.
Okay.
It is out there even today for Genoa platform.
Gotcha.
You can open it up. You can look at how we initialize the firmware.
Perfect.
Oh, the silicon, sorry.
All right.
Yeah.
Here's one more question for me. Yeah, I have a similar question as Suresi. So you build a library, right? So OpenSIL is a library.
Yes.
Yeah. So why not build like just a execution image? So then with a standard interface can be co-worked with the different OS loader, bootloaders. Yeah.
I'm not sure if I got your question. Are you saying that instead of it being a library,
Why it's a library? Why not it's just execution image? Yeah.
an
Why just build a
execution
library?
image
Yeah.
itself? Well, in a way, it is an so you need to be able to pass arguments, the parameters and whatnot, right? So how do you pass that if it is just a dumb binary image?
Such other competitors platform there has built one.
Oh, DDR.
Spec, yeah.
DDR is interesting. At least in AMD, DDR is initialized by the microcontroller,
Oh,
not by x86 firmware.
Oh, gotcha.
Yeah,
Thank you.
yeah. But even if even if the x86 firmware is initializing the memory, you can still you can still do it that way as well. There's no one stopping you from doing that.
Okay, gotcha.
Yeah. The design is extremely flexible. Yeah.
Hi. My question is, for someone that's starting with, say, EDK2, can you quantify how much effort or work would it take to get to the point where you get to basically the Aptio Community Edition image that you were talking about? How do you quantify that?
Okay, for Aptio Community Edition, yeah, the work we have already done it, so you don't have no other work. You just have to take it, learn it, understand it. But if you take a vanilla EDK2 BIOS and then start to integrate the OpenSIL 2 repos and then do the platform porting, yes, it will be some heavy lifting you need to do, spend some time on it. Yeah, it is not, it's just like any other system bring up. So you will have to go through all the pain, boot to OS, debug all those stuff. But yeah, community edition that we have given, you have the solution already. We have done all the heavy lifting for you. Thank you.
Okay, thank you.
Right.
Thanks, Raja and Srini. So
Thank you.
the break is coming. Let's be back on the 3:30. Yeah.
Sounds good.
Yeah. 1 hour break. Thank you.
Right. Thank you. Thanks everyone for your time and your audience. Thank you.